Welcome to International Steel Group's Burns Harbor operation located in Burns Harbor, Indiana. I'm John Mang, Vice President and General Manager of ISG Burns Harbor, and I'm pleased to bring you this video here today that represents not only our organization and our operation, but all of the men and women who make it possible by making steel products in a most efficient manner every day. If you are one of our many employees, you should be proud in the fact that you work for the finest steelmaking organization in North America. If you are one of our customers, we thank you for your loyalty and support. And now we bring you, through the eyes of the men and the women of ISG Burns Harbor, our operation.
We're in the coal field in the coke ovens, and this is actually where the process starts. And behind me you'll see the coal piles where the coal is brought in through rail and it is dumped by the rail cars, and then in the process behind me you'll see a stacker reclaimer. This thing has two functions. The function is it piles up the coal, dumps the coal into different piles. We use 4 types of coal. And then it also reclaims the coal, where it picks up the coal from the piles and sends it to our coal blending area, where the coals are blended together and then sent to the battery operations. We're standing on number 2 battery top. As the coal is processed through coal handling, it is transported to the battery top by the C41 belt to the battery bins, which are behind me. The battery bins holds the coal that is loaded into the Larry car. The Larry car actually brings the coal out to the individual ovens. The charging process begins when the Larry car removes the oven lids. The coal is then dumped in through the 4 screw hoppers into the oven. The Larry car then puts the lids back on. When the coking process is completed, which is about 18 hours after the coal is charged into the ovens, the oven doors are removed. And by using the pusher machine and the door machine, the coke is pushed out of the ovens, which is about 2200 degrees, through the door machine into the hot car, where it's transported to the quench station where the coke is quenched. We are on the coke side of the battery. This is where the coke from the oven, which is about 2000 degrees, is pushed through the door machine into the quench car, and then is transported to the quench station, where it is cooled to about 800 degrees, and then the coke is then transported back to the wharf, dumped on the wharf, and through a series of belt system goes to the screening station. The coke is then screened through the screening station and then transported down K4 to our customers at the blast furnace.
What we do here at Coal Injection is grind coal to the consistency of salt, sugar, and what it does is it replaces some of the coke that's needed on the furnace.
This is the beginning of the iron making operation, our dock unloading facility, our rotary car dumper, and our ore field. Approximately 90% of the materials that come into the Burns Harbor plant come in through this unloading facility. At the ore dock, all of our iron-bearing materials are unloaded there. We own 2 1,000-foot vessels, the Burns Harbor and the Stuart J. Court. They carry around 60 to 70,000 tons of pellets per cargo from our Hibbing Taconite facility up in Minnesota. The conveying system that we unload the belt is all automated from a J5 operator control room, and we will unload these ships at normally 5,000 tons per hour. We have 2 large stacker reclaimers, number 3 stacker reclaimer, number 4 stacker reclaimer, and these stacker reclaimers can stack out at a rate up to 6,000 tons per hour, and will reclaim materials for the furnaces or our sintering plant operation at 3,000 to 4,000 tons per hour. Our rotary car dumper unloads all the cars for the plant for coal for the coke ovens and coal for our granular coal injection facility. Our conveying system feeds 2 stockhouses, one for C furnace, one for D furnace, and our bedding plant complex as portion of our sintering plant operation.
My name is Denny Durko. I'm the iron making materials manager, and what you see behind me here is the sinter plant facility. This facility was constructed back in 1975. The purpose of the sinter plant is really to take a lot of the revert or waste materials that were generated throughout the plant, like mill scales and flue dusts and filter cakes and slurries. Take those materials, combine them with some natural ores and some natural fluxes, blend those materials over in our bedding plant facility into a material that is then sent to the sinter plant, combined with some trim material, some additional coke breeze. It's heated, fused together, and then delivered to the blast furnace. The sinter provides both the iron and flux for the furnaces.
Our iron making operation consists of 2 mid-sized blast furnaces, C furnace and D furnace. Our production capability is in excess of 14,000 tons per day. We have a strong feed-forward philosophy of ensuring high-quality raw materials. Our success is based upon good equipment, good operating practices, and excellent people. We supply hot metal to 3 facilities, to our own Burns Harbor BOF shop, to our Riverdale BOF operation, and periodically to our Indiana Harbor operation. Our blast furnaces are highly automated. The whole stockhouse feed system is computer controlled to ensure we have precise weights of the raw materials going into the furnace. Process actually is a gas-solid reaction where carbon monoxide is reducing the iron ore. We have 2 tap holes on each furnace. We cast iron at a rate of a little over 5 tons per minute, which is equivalent to producing 5 automobiles every minute.
When the raw material goes into the top of the furnace, we mill it down in the center, bring it down to the bottom of the furnace, and we have what we call a drilling process, which we'll swing the drill around, drill into the heart, which is the center of the furnace, to get the molten iron out. When the molten iron, once it comes out, we put in the submarine cars, then it's transferred over to the BOF, which is the basic oxygen furnace, where they do another process with it to turn it into steel.
This is the basic oxygen furnace shop, and this is actually the first steel that we'll see in the steel plant. We take scrap from other parts of the plant, we charge it into our furnace. We have 3 furnaces, and then we take metal, iron from the blast furnaces, put it in a ladle, we inject it to remove the sulfur. And then charge that into the furnaces. To get the heat, we top blow with an oxygen lance, oxygen at 3,000 cubic feet per minute. We inject it at about Mach 2.2. And at the end of the blow, in about 18 minutes, we analyze it. If the analysis is good, then we'll tap the heat, and we've made 305 good tons of steel.
We're here at the number 2 continuous caster here at Burns Harbor. This is the process where we transform the molten metal in the ladles from the BOF into a solid form usable downstream by both the hot mill and the cold mill. We make 10-inch thick slabs here, anywhere from 38 inches to 86 inches wide. The casting operation is actually a freezing operation where you put a molten flow in on top of a mold that's about 36 inches long, and the purpose is to freeze a shell thick enough so that when it drops below the mold, it has enough strength to contain the molten core as we control cool it down through the machine for a final solidification and a burning into slab length for further processing. The real key to the success of the quality product that's required by our customers is the skill and the ability of our employees to, through standard operating procedures and practices, to control the flow of steel, to shield it from oxygen, and to keep a solid, continuous flow of steel moving at all times.
Okay, this is number 2 caster run out. We received the iron from the top to cast floor. The cast floor gives us a slab that can be anywhere from 32 inches wide up to 86 inches wide. These slabs are then cut to slab lengths of anywhere from 140 to 385 inches long. Once these slabs are cut, they will turn the corner and go through the defrost machine. Once they go through the defrost machine, they will be weighed and laser width measured and then placed on the piler table with a tag placed on them for an identification. Once these slabs are identified on the piler table, they will go to a bay location, which at what time the slab hauler will pick them up and move them to a storage area. Once these slabs are put into the storage area, it will take approximately 48 to 72 hours for them to cool off.
You've just had a chance to visit some of the finest coke, iron, and steelmaking facilities anywhere in the world, and you've met many of the people who help make our business successful. We produce a high-quality slab, and the next step in the process is the hot strip mill.
I'm Jay Cook, Hot Rolling Division Manager. Today you'll see one of the country's finest hot rolling facilities. Our primary purpose is to take the as-cast slabs from steelmaking and produce high-quality hot roll bands. Our process involves slab conditioning, sorting, assembly, heating, rolling, cooling and coiling, and then shipping of the product. Please take a moment with me while some of the hot mill team members describe the operation in more detail.
We have 3 furnaces. Each furnace has a capacity of 750 tons. It takes approximately about 2.5 hours to heat a slab. Our slab lengths range from 146 long to 384 long. Our thicknesses range from 8 inches thick to 10 inches thick. When we drop out of furnace, we drop out at 2350. Time it goes to R5, we shoot for 2020. We have plans in the near future to upgrade our furnace to extractors for quality purposes.
This is the rough and mill area. We'll be receiving the bar from the furnaces after the discharge. First thing we'll go through is a visible scale breaker, which loosens the scale from the impurities formed from oxygen from heating the slab in the furnace. After the scale is loose, it'll be going through a series of high descale pressure to knock the scale off. Then it'll go through R1, R2, R3, and then R4, and then we'll have another descale at R5 to get rid of everything before the finishing mill receives it out of R5, which would be an inch 1.3 by the time it goes through R5.
Here in the finishing mill, we take product that is delivered to us from the roughing mill, typically at about 1.3 inches thick, and reduce it further into what we would call a strip, where it'll later be coiled down at our down coiler. Typical thicknesses at the exit of our finishing mill can range in the range of